All right. Hello, everyone, and welcome to the fourth and final Python workshop in the Python workshop series. My name is Jeffrey Duano.
And I'm your co-host, Marlene Salazar.
And today we're just going to be demoing some more advanced Python topics, more Python-centric topics. We're going to be demoing Python data collections, iterators, try except, using files, and classes and objects.
So previously in the last workshops, we learned about the basic input and output and data types and math in Python 3. We also did the functions and decision making like if else statements. And then we went over the two types of loops, while loops and for loops, arrays and their uses, and we went over NumPy and how to import other modules. If you guys didn't attend to those, it's okay. You guys can still watch this, and then you guys can go back to those in those videos for our Python workshops. So the first thing we're going to go over is data collections. And there are different types of data collection types in like Python. This includes lists, tuples, sets, and dictionaries. We're going to go over through each and every one of these. So we'll start off with lists in the next slide. So list is similar to NumPy array and is a collection of values, items written in between square brackets. So here we have like a basic use to it. And here, list name, you can name it anything you want. The only thing that matters is the way you write it. So here we use the square brackets, and then we use the parentheses, the quotations over it. If you're using numbers, you do not need the quotations. Those are just the strings. And then Jeffrey will go over the collab.
Okay, so how we're doing this collab this week is instead of going through each little detail about each of the topics, we're just going to show one or two examples about how they're used. So for this first one, we have lists, where a list is the Python data collection most similar to an array. Elements within the list are ordered and changeable. To declare a list, you have your name, you have the name of your list, which follows function and variable naming conventions. And then within square brackets, you have the elements that you want. You can have strings, you can have integers, you can have floats, doubles, booleans. So for this first example, with functions to note, append, and remove, this example has the list colors printed first. Then the color white is added to the end and the color blue is removed. The final list is printed. So you first have this list colors, and it is all the colors of the rainbow. Then as you go through, you print this list, and then with the append function, you add this to the end, white to the end, and then with the remove function, you remove blue from the function, or from the list, and then you print that out. And then whenever you do that, you would get what you printed out. So original list of colors should be the rainbow, and then the modified list of colors should be with blue removed and with white at the end. For the second example, we have with the functions to note, sort, copy, and clear. The list distance values is declared and printed with unsorted values. The list is then copied to a new list, sorted values, and sorted. The original list distance values is then cleared and both are printed. So you have this list right here with a bunch of numbers. Then you print out that original list. Then we make a new list called sorted values, which is the copy of this list. Then after that, you sort it, which won't affect the original. And then you clear the original, which means this will be empty, and then you print out both of them. So whenever you look at that, you have the original one, the new one, which should be cleared, and the sorted one. Next data collection we have are tuples.
And so tuples is a collection of data that is ordered but not changeable, and it acts like a list or an array with its elements, but it's in parentheses. So besides like the list, you know how it was in brackets, this one's going to be in parentheses.
So a tuple is a data collection that is ordered and unchangeable, as Marlene said. To declare a tuple, you do the name of the tuple, and then within parentheses, like she said, it will be the same types of elements as a list. And for sets, it will be the same. So for this first example, you have the function denote count. This example creates a tuple named character inputs and searches for how many times the character C occurs in the tuple. So you have this original tuple, which has all of these characters. So whenever you do, you have this this variable times C, which will return from the count function the amount of times that C appears in this tuple. So whenever you print it out, the character C has appeared in the tuple something times, it should return 3. Now for the second example, a function to note is index. This example searches for a value 35 in this tuple nums tuple and prints out the index that it was found. So you have this one, this tuple, then you have this value right here, which should return the index of 35 in this tuple, which should be 4. And then you print it out, and you should get 35 was found at index 4. Now, next data collection are sets.
And so sets, unlike the list and the tuples, sets are unordered and unindexed, and the elements within are written between with curly braces. And then you cannot change items within a set, but you can add items. So like when you're printing it, it will just print these in like random order, no specific order like banana, apple, cherry, Jeffrey wish.
So as we went over, this is how you declare the set. Within curly braces, these elements will not be ordered, they will not be indexed. So for the first example, some functions to note are update and remove. This example adds values to the set degrees seen and removes the value 90 from degrees seen. So you have the set called degrees seen, which is all of these values in degrees. So whenever you print that out, it should print out this entire set. So whenever you do update, you would add these values in no particular order, 50, 110, 125 to this set. And then whenever you do discard, you remove the number 90 from the set and then print it out, and you should get the new degree seen. You can see that the values, even though you initialize them in a certain order, they will not print out in any specific order. And yeah, for example 2, some functions to note are difference and union. This example has 2 sets, set 1 and set 2. And it finds the elements that exist only in set 1 and not set 2, and joins the 2 together into a new set, set 3. So you have this set 1, which is from 1 to 7. And then you have this set, which is just a bunch of numbers under 10. So whenever you do set difference, this will make a new set that's a difference of set 1 from set 2. Items only in set 1 will be in the set. So whenever you print it out, you should get that. Then we make a new set 3, which is set 1 union, which joins 2 sets together, and then it should print out this new set 3, which should be these 2 together. So here you have 2, 4, and 6, which are only seen in set 1. And then the 2 sets joined, since it's unordered and unindexed, and you can have the same value in it multiple times, or you can't have the same value multiple times. It'll just print out 0 through 9. And last data collection we have are dictionaries.
Yeah, so our last one is dictionaries, and dictionaries are unordered, changeable, and they're indexed. And just like the sets, it's like in curly brackets, except it has elements that are based on their key name and the key values.
So to demonstrate, a dictionary is a collection that is unordered, changeable, and indexed. Dictionaries are dependent on keys and their values. To declare a dictionary, you have the name of the dictionary follows naming conventions. And then within curly braces, you have this set of value keys and then values, all separated by commas. Pretty much you would be calling, if you were to call something in this dictionary, you would refer to the key of it, and then it will return the value. So the first example, functions to note, we don't have any for that one. This example creates a dictionary called person with key names Jack, keys name Jack and age 27, and modifies the name and age of the person to something else. So we have this initial dictionary, which has key name, and value Jack, and then this one, key age, value 27. So whenever you print that out, it'll pretty much print this in order. Then you can modify within the dictionary whenever you refer to the key. So whenever you go person, key, name, you can change it to John, and then same for age to 34, and then it should print out the new one. So here you have the original, name Jack, age 27, new one, name John, age 34. Now for example 2, a function to note is the pop function. This example creates a dictionary called drone specs with keys related to drone specifications, then removes the key price from drone specs. Both before and after will be printed out. So here we have this dictionary with the keys, model name, price, color, and battery life, and each with their own values. So whenever you print out this original one, it should print out all of these in order. Now you can use the pop function to just completely remove one of the keys and its values. And whenever you print it out, it will not show the price. So if we look down here, it goes through everything in the dictionary, the Mavic Pro, $15.99 stuff. And then you go to the new one and it doesn't have the price, the original price. Now next, we have iterators.
So an iterator is an object that goes through a data collection and contains the values of everything within the collection through iteration. So in other words, it's an object that contains a countable number of values, and you can traverse through all the values. And like lists, tuples, dictionaries, and sets, all of the data collections we just mentioned, those are all iterable objects, and they are iterable containers which you can get an iterator from.
So to elaborate, an iterator goes through a data collection, whether it's a list, tuple, set, dictionary, it can even be something like a string. It goes through it and returns a value from the collection when iterated. They will be used in conjunction with the next function in a method called the iterator protocol. Basically, you make the iterator that goes through something like a list, and then to go through the elements, you use the next function, which we'll show here. So in this example, with the function note next, the iterator will go through the given list using the next function. So you have this list right here declared with RGBCMY. And then you make an iterator called myIter. It'll iterate through this list whenever you use the next function. So whenever you print and then use next iter, it'll then go to R. And then next line, it'll go to G. After that, B, and then so on. So whenever we print that out, it should go through the entire list. Next topic we have is the try except block.
So the try except block lets you test a block of code for errors, and it can let you run a normally unrunnable block of code that may cause a program to crash. So here in the basic usage, X is undefined, and here in the basic, so when we add the try except, if the error is within the print X, then it will execute the except name error block underneath it.
So yeah, try except blocks are used when you want to test a block of code for errors. It will let you run blocks that otherwise would have caused an error. To use the try except block, you start it out with a try colon, and then just like functions, if statements, whatever, and then you can put your statements underneath. Don't mind the pass. pass keyword, it's mainly used for empty blocks and won't cause an error whenever you try to run an empty block. So you have this try statement. So if you're testing out a block, you put the block under the try statement. You test it for errors. If there are none, it'll go and pass this entire block. So if there is an error, it'll go to this except. If an error ever happens in the try block, this except block runs, and then everything below runs. And then after all that's done, you can use the finally block, which will run everything after the try block. So this example, no functions to note. This example will try to use the function count up that doesn't exist, thus causing an error and running the except block. So how it works, how the try except works is whenever it'll still go through it like normal, x equals 5, and then it'll print error before check. It will still print that. But because count up doesn't exist, it'll then cause an error. But instead of crashing the entire program, the entire script, it'll go to this except name error because the specific error is a name error. And it'll go and print this line, name error occurred. But this line will not be run, and yeah, whenever we try running it, it'll run up to before error check, cause an error here, move over, and then name error occurred. Next topic, using files.
Using files. So Python allows you to manipulate files in different ways, and you can read, write, create, and delete files within Python programs. So for example, you want to scan through a file that has different data values. This would be useful to sort through that file.
So this in the Colab is not runnable, but files can be manipulated in Python. To start, you can open a file by doing the following. You set an object file equal to open, and then it'll open this file that's in your default directory, and then R, which is a keyword for how the file is used. So in this first example, you have the functions to note open and read line. This example reads through a file called hello world text and checks if the first line reads hello world. So say we have a file called hello world text, and then the first line is just hello world. So you do file equals open, it'll open that file and just read it. It won't do anything else to it. And then with this if block, you can check the file, check the line of the first line of the hello world text. And then if it's the same as that, it'll run. And if there's anything different in this hello world text, it'll print this. This file is incorrect. Now for the second example, some functions to note are write and close. This example creates a new file called homework1.txt and writes in it foobar. The file is unclosed. So whenever you do file equals open, and then say this doesn't exist, right? It'll create it because of this keyword right here, W. So you make that, and then you do file.write, which will write in this file, foobar, in that line, that first line. And then you could close the file, and then later we open the file, read only, and then we print out what's inside it, which should be foobar. Now, last topic for today are classes and objects.
Yes, and classes and objects is Python is an object-oriented programming language, meaning that data manipulation within it is centered around data structures known as objects. And in Python, you can create your own objects using object blueprints called classes, and that can contain both data and functions. And Jeffrey will explain that even further.
Okay. So you can create your own objects or data structures using classes. Data structures kind of similar to like integers, floats, doubles, booleans. You can have within a class data or functions. So to declare class, you have the class, then class name, and then put your statements below. for what you want items in your class to be. So in this first example, function to note is this initial function. Another keyword to note is self. So this example creates the class person, declares an object, person1, and then prints out the properties of the class. So here you declare this person, and then you have underneath it this define initial. So pretty much this define initial means in this instance for the class. And then you do self, which is a keyword for an initial instance of a class, and then the other parameters you want for this class, which is name, age, height, and weight. And then you can declare all of these whenever you call on an object with the class person. Like you can call it with name, age, height, and weight. So then we create this object with the class person, which we just declared here, with the parameters John, name, 30, which is the age, 170 is the height, 170 is the weight. And then we print the parts of person one, which we can access with the dot name. And then dot age, dot height, dot weight, and then whenever we print that out, you would get the values you inputted earlier. John, 30, 170, 170. And then in this example too, a function to note, there's none for this one. This example creates a class called car with multiple properties. A car object is created called current car. Properties in it are changed and then printed. So we have this class car with the parameters name, year, and color. So then you create this new object called current car with the class car, and then the parameters name, year, and color. So for this current car, the name would be Toyota Camry, year 2007, color red. Then you print those values out and you would get these three. Then we change the values within this object. Change the name to Toyota Honda Civic, year to 2020, and then color to blue. And then you print out the new ones, and current car should have been modified. So whenever you do that, you get the original Toyota Camry 2007 red, and then the modified one, Honda Civic 2020 blue. And with that, those are the topics that we just wanted to go over today. So yeah. Thank you all for coming to the Python workshops in the past 4 weeks.